In this example, I'm going to look at the calculations on belt drives. Five point two. A flat belt has an effective tension. So effective tension is T1 minus T2. Is effective tension or is called effective pull. So T1 minus T2 is given as 350 newtons. The belt has a linear velocity. So the velocity, which is V, is given as 15 meters per second. The driver pulley has a diameter of 100 millimeters. So D, for a driver, we can use dA since the formulas will have dA and the driven will be dB. So dA will be equal to 100 millimeter. And the driven pulley, so let's label it as dB. So this will be equal to 500 millimeter. With the slack side force of 210, so slack side is T2, it is equal to 210 newtons. First question says, calculate the power transmitted by the belt drive. So as I have mentioned, the belt drives are straightforward. Formulas of the belt drives all will be given. Fe, which is the effective pull, effective tension is T1 minus T2. A tension ratio is T1 over T2. Power is Fe multiplied by V, and Fe is there. Velocity is pi dn, and small letter n is capital letter N divided by 60. Now, the belt drives formula are similar to that of gear drives, but where there is T, we put D for diameter. Where there is T is no longer a number of teeth, but will be a diameter. So we can use the same formula. Power transmitted. So power is equal to Fe multiplied by a velocity from the formula. So everything is given. Effective force, which is Fe, was given as 350 multiplied by velocity is 15. So you just use your calculator, 350 multiplied by 15. The answer will be 5250 watts as a unit of power. A question can say calculate it in kilowatts. You divide it by 1,000, then it will be 5,25 kilowatts. Second question, calculate the rotational frequency of the driven pulley. So in belt drives, if no slip occurs, the velocity is the same. So there is no slip that is given, no efficiency given. It means the velocity of the driver will be equal to velocity of the driven. A formula that has n is this one of velocity equal to pi dn. V pi dn. So when using that formula, it's V equal to pi dn. This diameter must be in meters and n must be in revolution per second so that you can get a meter per second for a velocity. Velocity is already given as 15 equal to pi multiplied by, we are looking for the rotational frequency of which pulley? Of the driven pulley. So we're going to use the diameter of the driven, which is 500. But this diameter must be in meters. So it will be 0.5 meters. 0.5 multiplied by n. So we divide both sides by pi times 0.5. Both sides pi times 0.5. Cancel out. So this will be 15 divided by pi multiplied by 0.5. The answer is 9,549 revolution per second. This is small letter n. If a question says calculate rotational frequency in revolution per minute, you multiply by 60. That is the relationship. Second question, rotational frequency of the driver pulley. Use the same formula. N is equal to, V equal to pi dn. If you make n the subject from here, it will be equal to V divided by pi d. Same formula, velocity is the same. Where there is velocity, you put 15 and you divide by pi multiply. A driver pulley now, you change it to millimeter, it will be 0.01 meters. When you change to meters, 0.01. You use your calculator to get the answer. Fifteen divided by 0.01. This one will rotate at 465 revolution per second. So it's 15 divided by pi times a diameter. And you get your answer. So the first diameter was given, or the driven is 500, which is 0.5. Yes. Second question. The driving pulley of the belt has a diameter of 130 millimeter and runs at 620. I think I should do this one in the next video. Let me do the second video.